So in my last video I showed how you could use a photosphere from Google Maps to visualize what the participants in the final experiment should see at Union Glacier Camp. Now I'm trying to visualize all the photospheres I could find, and I'm trying harder to narrow the range of where south could be in the photospheres so I could make more precise predictions of where the sun will be. This will require me to find the exact location of the photospheres. So here's a screenshot of Google Maps. I attempted to put in coordinates by eye, probably off by a dozen pixels. I tried looking at the alignment of features of Mount Rossmann in the photospheres to approximate the location of each photosphere. Orienting the Google Maps view south up made it easier to compare with the photospheres. The limitations of this are that Google Maps 2D view is not actually 2D, so perspective may be creating errors. And the mountain picture did not align with the elevation, so that's a big red flag. My estimations could also be steered off course by imperfections in the photosphere stitching process, or if there is tilt in the photospheres. I wasn't satisfied with this because to me the photospheres looked too far west from the only visible structures. So I thought, how about just using those visible structures? The camp does have some permanent structures. However, these may be buried under the snow and are hard to recognize from the Google Maps aerial view.
This is the startup tent, which has stayed on the ice all winter. It's heated by a stove, and all the meals for the startup crew are served here. This is one of several vehicles which stays on the glacier all year round. This is the comms box, the communications hub of the camp. It's situated next to a large radio mast to improve signal. These are the toilets. There's separate ones for men and women, and aren't particularly warm at all.
The toilets and comms have since been expanded. Between seasons, equipment is packed into storage containers. Among these is a freezer buried under ice.
This is the freezer. It's a shipping container that has been sunk into the ice and is accessible by a makeshift shaft. It contains all of the frozen food that has been left in storage whilst the camp is closed during the winter. The startup crew bring a few supplies with them from Chile, but the majority of food stocks will arrive with the first Aleutian flight. So until then, Ant has to work with whatever he can find here.
Good old beef fillet!
At the camp, the participants could get the exact geo-coordinates of these permanent structures, and they could ask the staff when they were built, if glacial motion moves them at all, and ask how much snow was on them when the startup crew arrived. It may be too late to use this information for predictions by then, but it could help reproducibility of the experiment and test to see if our current methods of predictions would have improved in accuracy or not, had we better data. With Google Earth time-lapse, we can see how much the camp changes. While not permanent, the rest of the camp maintains a general layout from year to year. A change in snow texture gives the same outline of the camp that we see in a brochure. I learned that the planes in this video are two de Havilland Canada DHC-6 Twin Otters and one Basler BT-67, which have a wingspan of 65 and 95 feet respectively. This gives us a scale for this image of the camp. With this information, you can get a general idea of where camp buildings could be. I made versions of the photosphere pictures that all pointed roughly south in order to compare their directions and locations. I made a rough map of where the photospheres are in relation to each other. Even though they're from different seasons, I tried overlaying the photosphere approximate locations on this aerial video. Now that I was distinguishing between different photospheres, I wanted to go inside the photospheres and measure the distance between them, each other, and the permanent structures. In the photospheres, there are shipping containers labeled with the ISO code 22G1. I found a site which gave me the dimensions of shipping containers with this code. All the shipping containers with this code are 8'6". Since the photosphere pictures are equirectangular, finding the angular height and altitude of the container is easy. I could then use law of sines to calculate the camera's height in photosphere 1. It was about 1.5 meters. With the camera height, I could use the tangent function to calculate the approximate distance of objects on the roughly flat ground. I wanted to apply this to other photospheres, so I tried to pick 2 points roughly in between photospheres to do this complicated application of trigonometry involving 4 triangles to get the distance between them, but it was getting too complicated, and my error range was getting too large to be useful. I had to call it quits. I thought about using a program that could do the triangulation better and automatically, so I thought of photogrammetry. But without enough perspective and no control point feature, all I could get was this ugly rendition of Mount Rossman. Maybe the participants in the final experiment could make a long aerial drone video for photogrammetry. I know Will Duffy has already planned to bring a drone and he got permission to fly it. They could bring tracking markers and place them in exact geo-coordinates. Now I had the problem of having 2 contradictory estimates. I decided to use the Google Earth time-lapse video as a tiebreaker. The aerial camp view positions 1 out, so the Rossman reference positions may be inaccurate for reasons I speculated previously, like how it seems the viewing angle of the mountain changed, so the Google Maps aerial image I referenced may have been erroneously projected. Okay, so while making the video I found out that Google Earth had a coordinate line feature which helped me align the present aerial view and the time-lapse with each other. Now that I had positions I was confident in, down to 100 or less meters, I had a tighter range for the direction of south and can do what I initially set out to do, which is to narrow the range of where south is so I could get a better range of what the participants may see in Antarctica. But if everywhere inside the camp fails, the participants could walk along the northwest path into camp that has consistently appeared in every layout of the camp I've seen.